Well, hello there. Welcome to live stream number 5. Today we're going to model a Jib Crane and also use some simulation functions in Fusion 360 to do a stress test on it. My brother and I talked about um, how we would want to make one while he was here welding up the parts washers, and we both come to consensus of what we wanted, except we decided to make it a little longer. And making it longer, we were like, man, that's, unless I go up in a next size higher I-beam, that's going to push the little one that I wanted to use. I'm planned on using the S3 by 5.7, which is just a little 2.5 by 3-inch I-beam. Just something small because I don't have but an 8-foot ceiling height in the shop. So I've never made one. We talked about it. I have all the confidence in the world in his welding abilities. So what we decided to do was to just look at one, and then we modeled one. So let me get over here to my center monitor here. And I just did a quick Google search for Jib Crane. And, looked how they were built, how the I-beam come across, how they were supported on the mast, how all that stuff worked like that. So to make sure how it would look and all that. So I got the measurements, and we, after the pieces that we had decided on using, I opened up Fusion 360 and I drew one based on all my measurements that I wanted. And this is the basic design we come up with. It has a 3/8 plate by 6 by 6 on the floor and on the ceiling. This will be screwed into 6-inch concrete, and this one, if we need to, will be attached to the ceiling. It might not need to. We might test it with just attaching it here at the bottom, but more than likely we'll reinforce that ceiling part in there with the top plates on the corner of that block, and then lag it to that ceiling part there. And then it has this part here is 3/8 by 3-inch angle iron, and this is that S3 by 5.7 I-beam. And we added this piece in here just for more stability and more to weld all this stuff together to. It might be better to put this one underneath and this one across the top. I don't know. We'll figure that out when Mike comes over here to weld this stuff up. So the first thing I had to do, so I'm going to start at the beginning here, is we opened up Fusion 360 and saved up a new drawing. And then the next thing I did was, I know that all the steel that is used around here, or that my supplier carries, is A36. So I went into the physical material properties and found, under the metal tab, scroll down to steel, and there's a bunch of steels, but I needed the A36. So if I can find it here quickly, A36. So we click on it, and what we do is we drag it over and plop it on top of there, and it's good to go. But I wanted to change color also, so after I did that, you can go up here and you can hit, I thought you could, yeah, the properties of it. So the appearance I changed to yellow because I'm going to paint it yellow. And then the physical properties, you can change the mechanical and the strengths based on what it is. So I double checked, downloaded my supplier's part, and they come up with the PSI, and this is the equivalent of that, and it was exactly the same thing. So we're good. I know we were good to go there. So now when we do the simulation, it should be all good to go. Well, I started off and I made a new component, which is the base plate, and I'm gonna go through this fairly quickly. Probably just be a 15 or 20 minute video. Don't want to go, the drawing has been pretty easy to do, so you just create sketches and extrude them up, and just keep on and keep doing that. So the next thing we did was I made another plate the height of the ceiling, which is in my case 94 inches. And then we added the mast, which I set it on a 45 degree, and the main reason I do that, the wall goes runs this way and this way, and I don't know for any other reason, that's the way I wanted to do it, so that's the way I did it. We can change it, it doesn't matter. And then we had to add the brackets, and what I just did was add a block I drew a sketch off the face of there, 3 inches by 3 inches by 3 inches. And then I came back and drew another sketch on the side and then took out the remaining part of it. So this is the shape of the 3 inch by 3 inch bracket. Then, of course, stop right here. And then we had that's the top support mount, and it's 6 inches below here. We might have to lower it just a hair because it gives me about, I'm gonna guess, 4 inches of clearance, and it might not quite clear those electric cords for where the LED lamps are turned on or plugged in. So we added the bottom one, and then I put holes in it. They're 3/4 inch holes to accept pins. So I put a thrust bearing on top in between these two plates here. So I copied and pasted these two brackets here and just flipped them over and added them where they needed to go. And then I had to import a DXF model for the shape of the I-beam. And then I just extruded the pieces I needed off of that and called out a new component every time I needed one. So I made one for the upright support, for the mast that comes out here, I'm sorry, the boom, and then this little support here. So I just drew all that up. It's basic, just sketches and putting it together. And I use joints to do that. In Fusion 360, let me highlight the joints here. I think some softwares, they call it assemble, where you have to slide in an XYZ plane. Well, Fusion 360 uses joints. So you can grab a part anywhere you need to grab it on these little coins. Let me see if I'll just do one right quick. So let me grab a piece of this stuff here. Just extrude a real quick little bit of it. And we're going to call that a new component. Hit OK. All right, then if I wanted to, just say I wanted to add it to the end of this mast here, I would come down here and grab it. What you do is you hit J for joint. Let me move my paper here. You hit J for joint, and you hover over anywhere, and you see all these little pick points, and you see this little coin, how it hovers. So here's where it'd be on this plane here on this corner, or on this plane there. So that's where I want that one. So I'm going to pick it there. So now it's knowing that I want to pick it there. Now it's going to ask me, where do I want to put it to? Well, I want to put it right on this point. You see all these pick points, but I want this one right here. So I'll click it there, and it'll come in and it makes a joint. So we just assembled that piece. So that's how you do that. You can make a rigid joint, a revolute joint where it spins, which doesn't make sense in this case, a slider joint, a cylindrical joint where it goes around the cylinder, a pin slot, which is like a train wheel, let's see, a planer, and a ball, which it would act, like it's a Heim joint or something like that. So I'm going to cancel that and get rid of it. Matter of fact, I'm going to back up one so I can get rid of the total thing. Mess up my whole drawing here. But that's how I put it together. Then, let's see, we added a short support piece that goes right in here. For nothing else, just more welding and more stiffness right here, because I'm sure this is going to be the weakest area. It's either going to be right here or right here. With all the weight out here towards the 9-foot end of it, it might put too much pressure here, but we'll see. And then, let's see, what's next? Oh, I created those joints and put it together, and then I put a revolute joint here. Oops, I thought I did. Back up here. Yeah. So this is how the boom's going to swing. And in order to get it to do the motions and stuff, you have to ground a piece. And of course, the natural part would be to ground this base plate. That's what the little pin says right here. It denotes that it's been grounded. But this is, not really why I wanted to do this video. I think most of us know, that use Fusion 360 or any CAD software about how to draw the things now. So what I wanted to do was to simulate the weight load, because me and my brother talked, and we figured the heaviest thing to to the middle of that table, or not even to the middle, to about 2 feet onto the table, would be at most 200 pounds. And I said, well, that's a good starting point. And he said, I doubt it'd be over 100, 150 pounds. And I said, well, let's just do 200 and we'll play it by ear there. So in Fusion 360, you can do what they call a simulation. So I'm going to switch to the simulation. You can do a static stress analysis. So we're going to click that and we're going to hit OK. And then the way Fusion 360 works is in all their things that you use, you go from left to right and you just work on everything. So the study is what we're going to do, a new stimulation, which we did. The simplify tab, I'm not sure what it does. So it says it creates and simplifies simulation models, but I'm not quite sure. I've done this a couple of times to simulate other stuff and couldn't quite get it to work, but I'm pretty confident in doing this now. So the constraints is the structural constraints. So where is it physically attached where it's not going to move? And I know it's going to be on this bottom part. We're going to start there. I don't think it'll pass, but we're going to try it there. And then we need to do the loads. What is the load going to be? Well, the load, I'm going to have a trolley, and it's going to ride on these two faces right here, and we're going to put 200 pounds on it. So it's grounded here or permanently fixed here, and our load is on the bottom of this web on these two faces on that trolley. So let's do the pre-check thing here. Oh, we got to do the contacts. What this does is it automatically detects where the contact points are, so the joints are, and where we put together stuff, and it does all that stuff. And when it's done, you get this little checklist. It says the study setup has all the information required. So now we're going to solve it, and I'm going to do it locally so we can see here, see how long this takes. I got a pretty smoking computer, so hopefully it can calculate everything fairly quickly. Either that or I might run out of stuff to say. But I don't look for it to pass this with a 3-to-1 safety, so it's going to have to do 600 pounds on the end of that 9-foot span, which I made it 10, but 9 foot is basically all we need, because by the time you do from the corner to here, you're probably a foot out with all the attachments and the hinges and stuff like that. So let's see what it does. It's almost done here, and it failed, of course. It only has a 2-to-1, which is way better than I thought it was going to have. And the deformation, of course, this is not realistic. It kind of makes it look way worse than it is. We'll hit the actual here. So the safety factor, which almost all engineering standards, you want a 3-to-1 safety factor. So it's showing you where the weak points are, which is where I thought it might be, right here in this hinge area, which you could box this in if you wanted to. And then up in this area here. And the actual, we can ask how far is it going to displace. So with that weight, you can see it pulling away from the original drawing here, and you can see it with it pulling away there and bending this rod bar also, which bending is good in some things. You don't, too strong and it breaks. So, bending is acceptable. So but it's saying it's 1.1 inches. So the best thing to do for me, like I said, it's going to be attached here, and it's going to be attached at the top. So we're going to close this out, and we're going to go back. Where are we going to go back to? The contacts. I'm sorry, the constraints. And we're going to add a constraint. We're going to add this constraint up here at the top. Whoops, missed it. Did I get it? I might have did get it. Nope, that's a vertex. I need this face. There we go. This one and the bottom one. It is already there. So now, zoom back out here. Everything has been changed. The only thing that's changed is we attached this to the top where it couldn't move. So let's, what's it asking us for? Oh, it's good to go. So let's solve it again. So we'll wait while it does it again. It didn't take too long. But having it 9 feet out, would be able to swing over to the table, and then it would swing over to the sandblaster. So if a part's too heavy to get into the sandblaster, once we modify that one where the top lifts off of it, or we build another one where the top lifts off of it, you can swing it over there and drop it into the sandblaster, have it sandblasted, lift it up, and then go right into the parts washer for washing, and then bring it over for rinsing. So it made sense. Now, there we go. We didn't change anything but added the other fixed constraint up there at the top. Come on, behave now. This other fixed constraint at the top. So everything looking at it, the max it should bend is 1/2 inch. It's well within the safety guidelines. So let's see this safety factor. It's still, the weakest areas are still right here and up in here, which that could probably easily be solved with just welding a plate over this areas and boxing these angles in. So I don't think we'll need to, but like I said, I'll ask my brother about it. But this is, validates your design anyway. So I really like it. I think this is going to be fine. So let's do another one. Except I'm going to use a bolted connection there and see if that matters. Let's delete this one. We're going to start a new one. Constraints, our structural constraints are still the top, this top plate and this bottom plate. Okay, and then we're going to have a bolt connector. We're going to put a bolt here. It's really a pin. Bolt would be the wrong word. And we're going to put a washer on top and a washer on bottom. Okay, and it simulates there being a bolt in there. So we're going to add another bolt. And if I'm doing this wrong, God, I wish one of these AutoCAD gurus would pop in here and say something about it. But or Fusion 360. I keep on saying AutoCAD. So let's see. Got that. Now we need to do our load. And that's not right. Let's cancel that one and do a load again. Structural load on this bottom face here and here. 200 pounds. Okay. Double click to get my thing back out. I think we've got everything. So we'll do an automatic contact again where it has everything within 4,000th is joined together. So that's what that is. So everything, whoops, it said it's not good to go. Maybe in. Let's see if it'll do it anyway. I think because I put a joint in there, it's not going to let it. But either way, I'm still very happy with the results. So it might not give us a result here. We'll find out. The computer working pretty hard. I hear it down there. The fan kicked on it. So you can render it on the cloud too. If you have other stuff you need to work on, you can just upload it to the cloud and it'll show the results when you're done with it. So it is thinking a little harder this time. No, we're still good to go. So of course I don't know why it does this adjusted deformation, because it really makes it look worse than it is. I'm going to put it back on actual and we'll go to the displacement. It's still just 1/2 inch. So I'm very pleased with that design. I'll ask Mike when he comes to weld it, which, matter of fact, I'll probably get him. The place where I buy all my metal is it's out in NASCAR country, and all they carry is pickled and oiled, and it's the closest one. It's very convenient, but the prices are just a little higher for pickled and oiled, where this doesn't have to be. And he has a place 40 or 50 miles from here that we might just order from there and go pick it up. And they carry all this stuff too. I'd have to order this piece of structural steel here from my supplier. So, but I'm very, very happy with it. So let's close that out. I like it. I like it a lot. So anybody got any questions or anything, hop them up there. Not that I'm not a fusion guru by any means. I'm just a guy in a shop that likes to build stuff. So, but I'll answer any of them that anybody has. I do like the way you can simulate the movements and stuff in here. And I went to Harbor Freight and just bought one of those inexpensive 1-ton trolleys that mount here. It's got the 4 wheels, and we're pretty either going to put a chain fall or an electric hoist. I know over the lathe we're more than likely going to build a gantry, and it'll have a chain fall on it, just because you can precisely lower it down in there. I don't want anything banging into that. But over here on the wash pits, we might use an electric one. And if we do that, then we'll probably mount a cord reel out here instead of dangling the wire and let it loops down on a guide wire. We'll probably just mount a retractable electric reel right here, and it can pull it out and pull it in as it needs it. So they're not that expensive, and like I said, we're not going to lift that much, and a 400-pound lift from Harbor Freight's probably not but $100. So I think that's what I'm going to do. So let's see. What else we got to say today? I think that's it. So what did we do in the shop this week? Oh, like I said, we cut the drain out for the wash pit, which is about 5 inches by, I don't know, 16 inches, something like that, and about 5 inches deep. And my plans were to layer they have a pig mat that'll only absorb oil, so we're going to lay that in there so it absorbs all the oil off, and then I can reuse my purple power that's in there. So we'll do that, and then that'll probably have layers of filtering material on it with pig in between them, so it can collect the oil. And I'd rather the purple power be reused as much as we can, so we'll probably do that. And then in the washdown pit, in the washdown pit, it's about a 5x20 slot, and we'll do the same thing with that. Filter that, put a piece of pig mat in it so it'll pick up the oils, and then the water can just drain off, and we'll put it in a catch bucket, and then before we make sure it's clean before we can get rid of that. So that's our plans. So anytime you have a shop, you always have stuff to do. So I reckon that's it for today. Let's see, what are we doing next week? Oh, the humidity here in North Carolina has been ridiculous. So the whole Sydney lathe has got surface rust on it. So we're going to have to sand that, but that's next time. So y'all have a great weekend. See ya.